Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at modular exponentiation. That simply means raising to a power modulo n. So for something like 13 to the power of 4 modulo 16, your calculator can help you because 13 to the power of 4 is not a big number. So you can just put on your calculator 13 to the power of 4, which is 28,561, and you can divide it by 16. Now, if you get that answer as a mixed number, you should get 1785 and 1 over 16. This is the number we want. This is the remainder when the division is performed. So 13 to the power of 4 is equivalent to 1 mod 16. Okay, but what about if we have something like 13 to the power of 19? So unfortunately, you can't reduce this number first. You see, if A is equivalent to B mod n, that doesn't necessarily mean that x to the power of A is equivalent to x to the power of B mod n. So we can't reduce this to 3 mod 16, unfortunately. We can still put it in our calculator, but we get a massive number in scientific notation. So that doesn't really help when we're trying to do something like this. So what we could do is we could start writing out small powers of 13. For example, 13 squared is 169. That's 9 mod 16. 13 to the power of 3. You can use your calculator like I did in the previous example. That's equal to 5 mod 16. We didn't need to do that here because we already know that 13 to the power of 4 is 1 mod 16. So we can write this in terms of 13 to the power of 4. See, 13 to the power of 19 is the same as 13 to the power of 4 raised to the power of 4. That's 13 to the power of 16 times 13 to the power of 3. So the reason that we do this is because these happen to be smaller numbers than 13. It makes our calculation easier. Now 13 to the power of 4, we already calculated that was equivalent to 1 mod 16. So 1 to the power of 4 is clearly 1. And then 13 to the power of 3 was 5. So 13 to the power of 19 is equivalent to 5 mod 16. We're breaking up the problem and making the numbers easier. Let's look at another example. So here's a really useful formula that can help you. As long as A and N are co-prime, then A to the power of phi n is always equivalent to 1 mod n. Okay, so how does that help us? Well, we're going to calculate 7 to the power of 90 modulo 15. Unfortunately, we can't first reduce this modulo 15, won't give us the right answer. But what we can do is this. So here n is 15. Phi of 15, remember, we write it as the product of primes. So 15 is 5 times 3. So phi of 5 is 4. Phi of 3 is 2. So phi of 15 is 8. So what does that mean? It means that because 7 is co-prime to 15, without even checking, we know that 7 to the power of 8, 7 to the power of phi of n, must be equivalent to 1 mod 15. So again, this works as long as A and N are co-prime, which they are in this case. So how does that help us? Well, 7 to the power of 90, we can write it as 7 to the power of 88 times 7 squared. 7 to the power of 88 is 7 to the power of 8 to the power of 11. That helps us immensely because 7 to the power of 8 is 1. So this is just going to be equivalent to 1 to the power of 11, which is just 1, times 7 squared, which is 49. And 49 is pretty easy to reduce modulo 15. That's our final answer for modulo 15. This formula is also really useful at helping us calculate inverses. So because a to the phi n is equivalent to 1 mod n, we can just take 1 off the power and find the inverse. So let's look at 8 inverse modulo 19. Now we know that phi of 19 is just 18 because 19 is prime. So before we check, we know that 8 to the power of 18 is equivalent to 1 mod 19. So 8 to the power of 18 is 8 times 8 to the power of 17. That must be equivalent to 1 mod 19, and that's what it's saying up here. We can just reduce the power by 1, and that gives us the inverse. So it must be the case that the inverse of 8 modulo 19 is equal to 8 to the power of 17. So to find the inverse of 8, let's just calculate 8 to the power of 17. So that's not easy to do, and your calculator may give you a really large number in scientific notation, depending on how many digits your calculator can store. So let's go ahead and calculate some low powers of 8. So 8 squared is equivalent to 64, and 64 is 7 mod 19. 8 to the power of 3 is equal to 512, and using your calculator, you can see that that's actually equivalent to 18 mod 19. And that turns out to be really useful. You might be thinking, well, 18's not a small number. How does that help us? It helps us because 18 is equivalent to -1 modulo 19. So how can I use this? Well, 8 to the power of 17, I can write this as 8 to the power of 3 to the power of 5. That's 8 to the power of 15 times by, I need 2 more 8s. Okay, well, 8 to the power of 3, we just figured out, is equivalent to -1 mod 19. So this is -1 to the power of 5 by 8 squared, which is 64. And this is all being done mod 19. Now, -1 to the power of 5, as it always is -1. 64, we figured out before, is equivalent to 7 mod 19. So 8 to the power of 17 is equivalent to -7. Just add 19, and you get 12 modulo 19. So that means the inverse of 8 is 12 in modulo 19. So that actually makes sense because 8 times 12 is equal to 96. 5 times 19 is 95. 96 is 1 more than a multiple of 19. So 96 is equivalent to 1 mod 19. 12 and 8 are inverses of each other. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.